How are you? My name is Robert Olivier, and I've been working with black soldier fly for about 20 years. I was an undergrad student, and we found black soldier fly bin in the compost bin, and we're amazed that what we were putting in was gone within a day. And obviously this process isn't composting, so we sent a sample to Texas A&M and said, hey, please analyze this insect. That was our first question, and Cliff Holscher was the person entomologist on the phone answering. And then we also asked the second question, is get us all the literature you can on this species. So a few days later we heard back from Texas A&M, and guess what they told us? It's black soldier fly. Whoa, okay. And we got 2 papers at the time. There was more papers, but I think he thought that we were crazy for asking. And so we got only 2 papers on how to eradicate them using common pesticides. And so now, almost 20 years later, we've gone a long way of looking at the beneficial uses of insects. And it's not just the pesticide industry that's funding entomology anymore. And so this is where I think the interesting opportunity lies, is that we're this transition of eradicating to utilizing insects. And so GrubTubs has worked on this quite substantially, but we're not the only company. When we're talking about specifically using insects for feed, there's lots of different companies globally taking place. The biggest, partially funded by the Gates Foundation, is AgriProtein, and they recently, on their last round of funding, had a $110 million valuation. And they're putting together these packages for factories all over the world, and the cost for a factory is about $15 to $23 million, and it's producing about 7,000 tons of meal a year. So lots of interesting aspects going on from when insects were just seen as a pest to utilizing it. However, these economics in these factories are extremely costly, and when I looked at those numbers, what was kind of crazy is that we're seeing that the investment that they're needing to do to get 1 ton of product produced a year is about $2,000. And they're selling the product at a really high price point, which is almost close to $2,000 a ton. So your return is actually really, really low. If we compare that on a per square foot basis, we're seeing these factories coming in and they're setting at $150, $170 a square foot. That's a lot of capital investment that has to take place. While a farm, nowhere near that price structure. When a dairy operation puts in dairy cows, it's not in a factory, it's in a barn, it's in a cheaper structure. And so bringing the insect industry to the farm is really where I think the next revolution is going to lie. So when we look at a black soldier fly factory with that high price point and valuation, and we look at an acre of soy, what we're seeing is that per equivalent of protein, an acre of soy is still out competing an insect factory. And so we really have to start defining this cost number that is associated with insect production, especially for feed, because soy is subsidized, it's highly been industrialized, huge economies of scale here. And so as aspiring insect startups, we've got a lot of hurdles to overcome. So when we look at this type of technology is how to go broke farming insects, it's actually really easy. It's some of it's property, plant, and equipment, a lot of it's labor. You can shift some of that labor and property, plant, and equipment by automating, but at the end of the day, somebody's still writing a check. And a lot of it's also feedstock logistics. What are these insects eating? And if you buy animal feed to make animal feed, you kind of messed up the whole thing. So we really have to look at waste sources and integrating or tapping into a very, very, very good sheet that pops up. So what I'm most excited about in having you guys as an audience is the biggest opportunity and cost lies within the biology. If you can work with the biology, you can affect labor costs, property, plant, and equipment, and logistics. That biology is not only the insects, it's also the microbes. So the second thing that I want to do is, a lot of you guys are young aspiring entomologists, and what you do in the classroom, I'm sure professors have said, hey, our colony's doing really well, I got this great postdoc, You know, he's taking really good care of his colony. But when it comes to industry, we got to think about the most common, dumbest denominator. And so we got to think about how to do this not with postdocs, but with agricultural labor resources. So where all of this comes in is the biology is super important here. And so I'm asking you guys to think outside of the tray. The tray is the bottleneck in this point, where we saw Aspire talking about all of this manual labor that goes in. This is great when it's a research facility, but start thinking today about how to change that process, how to make it from batch to continuous, how to make it ongoing. So we're looking at a competitor landscape right now when we saw agri-protein was about $170 a square foot of investment. But you look at a typical farm infrastructure investments, it's around $25 a square foot. So we need to drive the investment down, and then we also got to get the operating costs that could be anywhere from $2,000 a ton to about $200 a ton. Now, that'd be great. And the way to do that, in my humble opinion, and it's an opinion, is to go from factory farming to farming. Doing this where we collaborate with farmers, and you guys being academics, this should be the ultimate, I think, hook. Because by supporting farmers, if you can work from a research perspective and get a farmer to do this successfully, the farmer's the first guy to tell you if it's going to make money or not. You know, he's not going to he's going to respect your opinion, but he's going to do all of the back of the napkin calculations very, very well. So I think that's the biggest litmus test when you're in an academic setting, is saying, hey, let's actually listen to what the farm has to do. Can I switch now? Okay. So what's needed? For example, our goal is to make a black soldier fly animal feed at about $600 a ton. What is that? That means that we're a little bit over conventional feed costs, soybean $400 to $500 a ton, but we're way below organic. Also, the feed, specifically what we're looking at is poultry, so it's only 20% protein versus fish feed that's around 50 to 60% protein. The reason this is important is that actually has a huge market if we can hit those price points. But in order to do that, what's needed? I told you about biology, right? That's the number one thing. By understanding the biology, getting the biology down to $200 a ton, that is really, I think, the inflection point. You know, when Al Gore talks about, grid parity in the solar industry, this is feed parity. And once we can get past that hurdle, you can see things stay up. Also, the farm technology, let's get the equipment down, or the infrastructure cost down as close to $225 a square foot, kind of like a dairy farm is. And then the nutrients, well, if you buy animal feed to make animal feed, you're really defeating the purpose. So we got to get the nutrients out of the city for free. So that's a lot of logistics and other types of management. So we're working on that. What's needed from you as entomologists is, when it comes to the biology, there's a lot of cost in climate control, but there's a lot of opportunity in genetics and behavior. Because if you can get, the poultry industry does that. They have specific chickens for specific regions in the country. We need to think about that. We want to implant that idea. Also, when we're talking about farming and equipment, stop thinking about doing everything in trays. Can we do it with tractors? Especially if you're a land-grant university, you have access to farm equipment. Go crazy. Think about how to feed this with tractors from day one. It's going to open up a lot of development and save a lot of headache trying to take a business model that was done out of trays and scaling it up to tractors later. And then the biggest thing to me is to go from batch to continuous. If you can really develop a process that works with the biology, that just never stops. That means that we can do it in a smaller footprint, so density is very important. So, also, to just hone in on the first one, because of you guys as entomologists, if we can get the biology at $200 a ton, the ecosystem for insects is going to need hatcheries, which require experts. But it also needs genetics and breeding in order to go against those other cost factors that we're seeing, or bottlenecks. And that, I think, is a wonderful opportunity. And so when we then look at the entire ecosystem, I want to put you guys there as both influencers for university and government. And those then affect, again, the equipment and the biology that we need. But instead then focusing on just a huge factory that's $150 a square foot to build, let's focus on empowering farmers to have the equipment. So the equipment is concrete slabs, hoop houses, very simple infrastructure. Farmers know how to fix themselves. They don't need to call us to do it. And if you can work within those constraints, then the next aspect is integrating the city with the farm, which is a logistical play, and that's exactly what we're doing with Grub Tubs. So we're picking up food waste here in Austin because of an ordinance that's requiring restaurants to do it, and we're offering the restaurants a price point that they pay us about $12 to $35 a week to come pick up. That helps us tremendously on the logistics, and it actually saves it's actually cheaper than composting and the gate fees that are associated with it. So we're offsetting part of that gate fee requirement that Austin is facing. And at the same time, because of the fact that we are targeting that price point of $600 a ton, what we're seeing is a typical local farmer would save about $40,000 versus buying organic feed for every 3,000 layers he has. That's a livable cash flow that wasn't available to that farmer. And that's the unique thing. If you think about what GrubTub stands for, are we the next eco-protein company? No. But what we're really about is empowering farmers to be sustainable within their food sheds, independent of big corn and soy. So we made a feed together with Coyote Creek that was it was an organic feed mixed with black soldier fly. That's not been organically approved, by the way. But we got all the organic soy out of the equation. The feed cost dropped from 45 cents a pound to 29 cents a pound. 4 cents a pound in the feed market moves the market. We're almost 20 cents efficiency. And that's where I think we really want to come in. So if you're talking to your department head about why entomology is so important, it's not about killing insects anymore. What really is important is that you're looking at a way to empower the American farmer to stay in business. Because if we integrate the farm with the city, that food waste is not going to be transported to the Amazon in order, where they clear cut it and then do it and then send us food back cheaper. No, we'll be able to recycle these nutrients close to where we consume these nutrients. So insects for feed is a very simple model in theory, but it needs a lot of support by the academic world. And who are you supporting? There's lots of startups, but more specifically, you could be supporting this entire notion that the American farmer is not completely based on plant-based animal feeds. If you look at all the agricultural acreage in the United States, 70% of it is dedicated to plant-based animal feeds. And by unfeathering and by recycling nutrients from the cities, we're looking at a tremendous opportunity. Anyway, my name's Robert Olivier. I'm with GrubTubs here in Austin. Follow me at GrubTubs on any of those social media sites, or call us 844-GrubTubs, or sign up on our website.